All right, everybody, welcome back. We're going to start with an overview of the TCP/IP model. Why? Because now Cisco talks a lot about this TCP/IP model. All right, let me just show you what I mean. Here we have a nice little diagram. Obviously, I took this from them. All right, we have the OSI, the TCP/IP, and TCP/IP again, because this is the original layer 4. There's 4 layers: the application, transport, internet, and link. All right, but now Cisco is using a 5-layer TCP/IP model: application, transport, network, data link, and physical. They actually took the link layer and they broke it up into 2 pieces, making it a little bit more, I guess, if you want to call it micromanagement, or more to separate certain things from just everything on the link layer. They want to explain things on the data link and then on the physical. So they're becoming like an OSI. All right, like an OSI. But this is your TCP/IP model. Something you need to know, something you need to memorize, this something in networking that was the original model. And with that said, here, now you may not be able to see this, but you'll see it when you have it with you, when we upload it. There's a link to a particular website, all right, which shows you a timeline of the TCP/IP when it started. They're not going to ask you history questions. They're not going to ask you who's the father of TCP/IP or anything like that. All right. But if you just Google timeline for TCP/IP model, that will come up. But the link is there. You can always click on it and you can go ahead and go onto it's right underneath here. If you can't see it, it's in brown, but you'll see it once the course gets uploaded. You'll be able to see it just fine. It's an internet timeline that you can actually move. You have to go to the year 1973. That's when the TCP/IP model was actually started its design, right? Its creation, right? Way back in those days. All right, so that's something that's good to know. But what you need to know, and you can see that here, even in their timeline, they have just a 4-layer model, but now they're separating the internet and network, or internet and link layer, all right, I should say, internet and link layer, into two separate data link and physical. All right, so the internet is 1 layer, but then the link layer is data link and physical layer. So they won't be talking about the same things on each layer. So what does that mean to you when you're taking your certification? Pay very close attention to the question. What is the new TCP/IP architecture? The original TCP/IP architecture has how many layers versus the new TCP/IP? What layer of the TCP/IP model was broken into 2 layers? The data link and physical. Oh, that was a link layer in the original TCP/IP model. So those are the things that you may run into, okay, in the test. Is that now we have a new 5-layer TCP/IP model, but it's essentially talking about the same thing. It's just been divided into other 2 layers. All right. Well, with that said, remember, this is your TCP/IP model. This is what we use. All right. We still use the OSI, but apparently for some reason we like to stay close to the TCP/IP, the original model that was created way back in the day. See everyone in the next lecture. All right, welcome back, everybody. We're now going to look at a perspective of different networks. We talked about the TCP/IP model already, more or less, a little overview of it, what they are. But not all networks are equal. They are not. From the devices that we use, from the configurations that we use, everything is different. So I made 2 examples. Here you will see a home network. Obviously, I don't have, Comcast router or things like that. So basically, what do we have here? We have a wireless router, and this is like a Linksys type router, okay, or a D-Link or whoever, okay, that's giving wireless connectivity in your bedroom, in your study room, in the family room, by the pool, where you're at, in the bathroom. Don't do that. I've troubleshooted that before. A guy called in. says, yes, my laptop broke. It just went up into smoke. And I asked, well, where are you? I'm in the bathroom. Well, why are you in the bathroom with your laptop? He says, well, I was going to take a shower, and at the hot rod run, the steam came up. Well, the steam obviously went inside your laptop, and you fried your freaking laptop. So don't, we know we get wires in the bathroom. Don't take your laptop in the bathroom. Okay. But anyway, small office, home office network, right? If you want to call it that. But that's a common home network. Common. We know we have individuals that have racks and servers and SANs and everything inside their homes. But for the normal individuals that are out there, for the everyday user, they have this. They have their wireless router. They'll have a switch, possibly, if they wanted to connect other devices to it wired. Okay, which I do. I do. And then you have your, obviously, the modem slash router that they have in your particular network to get you out into the internet. And here we have a business. This is a business, right? You have the third floor, the second floor, the first floor, and it's all VLAN out. We have the accounting department, the finance department, and the HR department. And we also have the company router, and of course, to get out to the internet. The difference is here is that we have more different types of equipment, but we also have different types of configurations. There's a very basic configuration. These laptops, as you will see now, all right, I'll bring it up so you can see it. Desktop and not there. Okay, I'll do an IP config. IP con. I can't even see. All right. IP config. No. Oh, IP config. All right, it's getting DHCP an IP address automatically. All right, and a gateway automatically. You're not getting it, statically. I should have just shown you right here. Really, that would have been a lot easier. Just to show you right there. Oh, I am doing it statically. Never mind. That's what I do because when I set up wireless, I have the habit already of putting everything statically. I disable the ACP and all these things, but when we get into security, we'll talk about that. But I do disable the ACP and all that. If I go to users, which I've done in the past, I do that for them as well. MAC addressing, all these different things that you can do. But this would be in a home network. Here, we have a core switch, which has all the VLANs, which they populate down to through the trunks. And then here you have the VLANs where you assign them to the access ports. And of course, those access ports, you turn off spanning tree, you put in switch port security. I didn't put any firewalls, but definitely in networks, you will be using firewalls. You can either put them before the router or after the router, before the router. Or before the router, what would it be? I guess based on the perspective, before and after the router, you can put them one in between right here, each VLAN. You could do that for an overkill, right? You can set up, global servers, email servers, all these different things. So there are different types of networks out there. They're not all the same. They're not all running the same type. They're all not running Cisco. They may be running D-Link. They may be running Netware. Not Netware. They could be running Netware. I don't know. They could be running Juniper. They could be running a whole bunch of different routing types, F5, all different types of routers. But essentially, the concepts of networking is the same. That we want to get from point A to point B without having to use our sneaker net, right? We don't want to have to walk anywhere to give people information or send it through email, the Pony Express, or whatever the case may be. We want to send it through our network to get to our wide area network, and we want to do that securely. So depending on where you're at, and unfortunately, when it comes to home networks, there is a lack, of security because people do not pay attention to that. And that's where we come in. This is our job. Even though we're already working in an IT field, in an IT department, hey, but it never hurts to do things on the side. You go out there and you educate or you help people and say, listen, it could be your friends, could be your family members. You should do your wireless this way. You should configure this. You should buy a software firewall. You should buy a hardware firewall and explain to them and maybe help them configure it and secure it. But definitely not all networks are equal. When we're talking about wide area networks here, are we running MPLS? Are we running DM VPNs? Are we using BGP routing protocols in itself? So all these things that as a user, you really don't do. What do? You go to the store down the street, you buy yourself a wireless router, you plug it into a wall, you plug it into a switch, there you're done. You're networking, right? Or you plug it into your modem, because nowadays modems have modem/routers. Just plug it in and you're done. And you're done. And everybody you're pretty much in your neighborhood can get your wireless unless you secure it, and then everybody's online. Okay, so that's one thing that the Cisco wants you to be aware of. They want you to be aware of the fact that not all networks, and not only not all networks, not all devices. These are 1841 routers. There's different types of routers out there. There's different type of IOSs. Just like in Microsoft, are you going to be using Windows 98 nowadays? Windows 95? I think not, right? We're going to be using the latest and the greatest, right? We're going to be using Windows 2010, or some of us are still using 2000, what was it? Windows 7. I'll say about Office. Windows 7, okay? That we're going to use the latest technology because everything has an update, everything to bug fixes, right? Where the back doors are being closed. There's more security. There's things that they've upgraded to help us not only navigate the operating system, but to also give us features that will help us secure our network. So these are things as users, regular everyday users, don't know, but this is our job. We should try and educate as many people as we can. And hey, it's money on the side. And here in your IT, in your field, in your job, definitely you need to make sure that all the equipment that you have, that you be aware of all their features. That's why licensing is now part of the CCNA 200-125 exam. Okay, you'll need to know about that because every operating system, every iOS will bring a certain feature set, and you need to activate that feature set. Okay, so you need to make sure that they're all up to date. All right, and you know what they are, what they're for, and how to configure it. Well, there you go. These are both our different types of networks that we deal with. And as we go along, we'll definitely look at other types or different configuration of networks when we start creating our topologies with our different routing protocols. I'll see you then. All right, everyone. Now we get to go and break down each layer of the TCP/IP model. Let's go ahead and start with the application layer. Now, some of this should be familiar to you because of the OSI. All right, if you didn't know about the TCP/IP. If it's not, well, hey, now you're learning. The application layer are considered the communication protocols. When you're sending email, what do we use? SMTP. When you're going just browsing in itself, what are we doing? HTTP. If we're doing email, right, through, let's say, some form of web browser, right, webmail, we can use IMAP or POP, right? We have DNS we use on a daily basis. We can do FTP, DHCP, a routing protocol, all these things, RIP, SIP, when we're doing voice, all these different things are actual communication protocols that are nearest the user and nearest the network. They're the ones that go out and see if the network is ready to receive information. They check all that. So when we're talking about the application layer, and if you're asked a question in your certification exam or just or an interview or anybody trying to be funny with you, okay? If you talk about application layers, protocols, or you're talking about application, what works at the application layer. Don't say like things like Excel because it's an application, or Word or anything like that. No, what they're referring to are these communication protocols that actually access the network to see if it's possible to send information and how we send this particular information and through where. Like here, we have SSH, which uses port 22, and Telnet, which uses port 23. One's encrypted, one is not. So there's many, these are not the only ones, it's just some things I threw up there. Okay. Again, do you need to memorize this entire list? Memorize the more common ones. Understand that this is what they're talking about. So when you take your multiple choice test, you say, oh, okay. Just to throw something out there, if I, an administrator, want to send an email to a remote user that at 2 o'clock he needs to upgrade whatever, or he needs to be at a meeting, well, what's the highest level that I'm using in the TCP/IP model? The application layer, because I'm using the browser. So these are the ways that you may be tested. But again, application layer protocols are communication protocols. They're not actual applications. They're protocols that access the network. All right. Well, with that said, I'll see you in the next one. All right. Off to the next layer. What layer are we doing now? We just did the application layer. So we're doing now the transport layer. Yes, this is considered the host to host communications. All right. This is where you're going to see your TCP, your transport communication protocol, your UDP. This guy right here, what's it, Uniform Data Protocol. This guy right here is what we don't want to use, right? Because this is connectionless. This is connection oriented. More importantly than these right up here are windowing, acknowledgement, negative acknowledgement, sequencing, and error detection. This is what goes on here. The analogy that I like to use, which I use the same analogy for the OSI model because it maps over directly to it. Imagine yourself unloading a truck. You got this individual up on the truck and you're down here ready to catch the boxes. And you say, hey, I'm ready. So you ready? It's the acknowledgement. I'm ready. Okay, here you go. Here comes one box, one byte. Boom, sends it. Boom, got it. Cool. Put the box down. Ready for the next one. Sends you the next one. No, one box. Sends it out, puts it down. But now you said, hey, give me two. So he says, okay, I'm going to send you two. Sends you two at a time. That's the windowing that's happening, right? Because you can handle two at a time. That's TCP. TCP is the protocol of the internet, actually. TCP/IP, that's what we use in the internet. Okay, there is no more Apple talk. You could use it, I guess, just within Apple, but everybody speaks TCP/IP. Okay, so because it is connection oriented, it does that three-way handshake with the acknowledgement and negative acknowledgement. Hey, listen, I didn't catch the box. Hold off. Okay. Oh, hey, you didn't send me that box. Can you send it again? Because I didn't get it. All right. So that's what's happening. All right. With the TCP protocol. UDP, using the same analogy, will be the guy on top of the truck. You will be down there. He can care less if you catch the box or not. He's just going to go like this. Just keep throwing the boxes. And you're like, oh my God. Oh, that's what happens with UDP. Now, we looked at the application layer. We saw that DNS works there. DNS does use TCP and UDP, both. But there's a fine line that divides that. If DNS is looking for a host name or a computer name, it'll use UDP, very small packets, right? Very small packet. But now, if it's doing synchronization with another domain controller, with another DNS server, well, that's important. So it's going to use TCP. All right. So sounds like a test question. What protocol may use both TCP and UDP? DNS. Okay. So it all depends. We do use UDP a lot, especially when we do, let's say, we use TFTP, which also works at the application layer, where it's called the trivial file transfer protocol, which is a connectionless. It doesn't use TCP at all. All right, but it's very quick because the TCP header is very huge. The UDP header is not. The UDP header is not. So that's why UDP is very popular when it comes to file transfers and things of that nature, something very small. But TCP is definitely what we need for the internet because, hey, that's a humongous network out there, right? huge wide area network, global wide area network. We need to make sure that we get where we need to go. So we need that three-way handshake. Yes, I am ready to receive. Yes, I did receive that information. Let me let you know that's happening, or let me let you know that that's not happening. All right. And of course, it does the error detection and sequencing. As things come in, they come in a certain order. And as they go back out, they go back out in a certain order. And all these things, there's checks and balances. So TCP is a very important protocol at the transport layer. All right. And it will communicate, obviously, with its host on the other side as well. All right. But we'll talk about that later on. We'll talk about that later on. So, this in a nutshell is the transport layer in your TCP/IP model. See you in the next. All right. Now we get down to the network or internet layer of the TCP/IP. Can go either or, same thing. Okay? Network or internet layer. What does it deal with? Internetworking. Yes. This is where we see IP. Okay? Our routing protocols work here as well. Our emails or multicast protocols like IGMP, but routing protocols, routed protocols like IP version 4 or 6. ICMP works at this layer. Okay? But we'll get into ICMP version 6 when we get to IPv6 because ICMP v6 is special. Remember, IPv6, no broadcast. Therefore, ICMP v6 has a lot of work to do for when you're addressing an IPv6. But the network layer is very important because that's where everything is going to happen. Where's it going to go? Are we dealing just with IPv4? If we are, the ARP that needs to be sent out. Okay, so we need to know what's going on this particular layer. Security, as far as IPsec that works on this layer, is one of the other ones that we need to, when we're configuring, let's say, a GRE tunnel that's plain text, we secure it using IPsec. Definitely is working at the network layer. There is a difference between routed and routing protocols. Routed protocols are things like IP, IPX, things of that nature. Routing protocols, we know these. RIP, EIGRP, OSPF. Now we have BGP that we'll be dealing with as well. All right. So be ready for that. All right. So, but this is what happens at this layer. And all this, and you'll see it shortly, that maps over to the OSI model. It maps over to the OSI model. All right. But anyway, so this is your network layer or / internet layer. It can go by either name. In your certification, they may ask you that. It could be application, transport, internet, and link, or it could be application, transport, network, and then link. So it all depends how they want to do it. All depends on how they want to do it. It could be either or. Just remember we have a new 5-layer one, which is data, link, and physical. But again, when we do our summary, we'll take a look at that again. All right, there's your network layer. That's what they're responsible for. Things as routing, routers, they're the ones that handle things at this particular layer to make sure that the path things are taken, depending on the routing protocol, goes in the right direction. And thanks to the transport layer, we make sure through TCP that it gets to where it needs to go correctly. If not, it'll let us know that, hey, there's a problem. All right, so there is your network layer for your TCP/IP model. I'll see you in the next. All right, now we get down to the bottom of our TCP/IP model. Now you know that they've broken it down into two sections, data link and physical. So they've combined everything that, well, they've separated actually, not combined. It just used to be the link layer where it was our, I don't know why OSPF they would put it there, but they did. OSPF, well, the tunneling. All right, PPP definitely worked at layer 2, the data link. Wide area network protocols. MAC addressing works at layer 2. When we talk about the physical layer, we're talking about bits, cabling, connectors, hubs, concentrators, things of that nature. So I think that's the reason that they broke it up into 5 layers, so they can make that distinction between the wide area network protocols, even though wide area network works at both layers. All right, just like wireless works at both data link and physical, but they actually separated it because the physical layer only deals with physical aspects of it, zeros and ones. They deal with, like I said before, the cabling, whether it be fiber optic, UTP, coaxial. It doesn't really matter. It doesn't really matter. So it's just the different type of medias that work on that particular layer, on the physical layer. So they have separated it, but definitely know that the data link layer, okay, of the TCP/IP or OSI model, all right, that is the physical topology at work because you're running your cables and all that. That's what that deals with. Definitely the switches, the MAC addressing, all right, the frames. And when we get to and the wide area network protocols, they work at that layer too. And when we get down to the physical layer, all right, then we get dealing with all the cables. So all they did, and we'll go over in the summary, all it did was just break it down. What before was just a link layer, okay, they actually made it into 2 separate layers: data link and physical. So you can get a better understanding. And again, the OSI would always give us that understanding anyway, but they decided to put it in the TCP/IP model. That's it. That's it. But when we make the comparison in the summary, you'll see what I'm talking about. I'll see you there. All right, we've come to the end of this particular section. So let's do a summary of the section. Let's take a look at what we've talked about. Definitely, we talked about the TCP/IP model. We saw that there were 2 TCP/IP models, right? We have the 4-layer application transport internet and link, or it could be called network. It's okay. And then we have application transport network data link and physical. That's the one they're using now. That's the new one Cisco put in their certification exam. So be wary of the questions that you're being asked. Read carefully when they talk about which TCP/IP model is in use, which is 5-layer, is there a 4-layer, what are the layers, things of that nature. What layers were broken down? The link layer was broken down into data link and physical. And just so you know, I should say it right here. Figure 1-15 OSI compounded to be 2 TCP/IP models. All right, this is from the actual official cert guide. So I'm not pulling this out of anything. This is straight from them. All right, so now you know. All right. And again, everything maps over to the OSI model. Everything maps over to the OSI model. As you can see, transport, network to internet to network, transport. It's all the same. That has never changed. Whatever happens in the transport layer goes all the way across to the TCP/IP. Whatever happens in the network goes to the internet and the network. It's the same thing. Think about it. The internet, you're networking. What are you doing in the internet? You're going from one network to another network. How do you get there? By routing. So you're whether it be a routing internally in your office or you're routing out into the internet, doesn't matter. So everything happens there. And then transport, obviously, the TCP, the connection oriented, the sequencing, the windowing, the acknowledgments, all that good stuff. And then the physical is the physical. Oops, sensitive board. The physical is the physical. Here we're dealing with our cabling, all right, our concentrators, our connectors, our hubs, things of that nature. And then we have, where it be, DCE, B.35 cables, serial cables, crossover cables, data link, dealing with frames, all that. So know how this maps over to the OSI model. It's not that difficult. Know that there's now new 5-layer TCP, which is not new. It's been around for a while. All right, but now they're adapting it. All right, and we did break down each layer, what protocols work in each layer in the TCP/IP model. But remember, whatever protocols work here. Okay, as you can see that. But again, once we get into the OSI model, we'll talk about the OSI model again briefly, just so you get an understanding. Because remember, All these standards are blueprints. They're just guidelines that we follow to help us network, to understand how networks work. That's all they are. Okay? Guidelines, blueprints for us to follow. All right? Well, that's it. That's what we went over in this particular section about the TCP/IP model, the types of networks. Don't forget that, whether it's a small office, home office, or it's a business network. And then we took a look at each layer of the TCP/IP model. See everyone in the next lecture.